Okay, this is a lesson 62 on quadratic functions. The objective for today is you'll be able to identify quadratic functions. You already do identify them, so this is going to be quite a bit of a review lesson. So, just as a quick review, whenever you're seeing any sort of functions, if it's an equation, let's say y is by itself, let's say y is equal to x plus 1. What's the exponent above the x here? 1, right? What's the exponent there? 1. So this is called a linear equation or linear function. Here's another one. Y is equal to x squared plus 1. This is a quadratic, right? This isn't anything new, by the way. You all know this, right? And then if we have y is equal to x cubed plus 1. X cubed plus 1 is a cubic function, cubic. Okay? So we look for the x, and then we see what's the biggest exponent on the x. X the first is linear. If it's x squared, quadratic, x cubed is cubic. Okay? So we're going to be doing these steps today. When graphing quadratics, we're going to figure out the vertex, graph it, we're going to find the domain, find the range, and use the vertical line test. Okay? Here we go. So number 1, sketch the graph of each function. Watch me do number 1 and 2. Okay, number 1, first thing I want to do is figure out my vertex, and vertex, remember, is negative b over 2a. So I think about what goes into, what makes negative b over 2a? Well, I know a is equal to 1, b is equal to negative 2, c is 0. So negative b would be negative 2, which is positive 2, over 2 times a. 2 times a is 2, so positive 2 divided by 2 is just 1. So instead of negative b over 2a, I'm just going to put 1 in. And then to figure out the second number, you just plug it back in. So you put it back in here. 1 squared is 1. Negative 2 times 1 is negative 2. So 1 minus 2 is negative 1. Okay, 1, negative 1 is our vertex. So we're going to plot that, 1, negative 1. And this is our vertex. Okay? Then we're going to figure out our points left and right. So we have our x and our y-axes. And this is one way I showed you how to do it before. Is we got 1, negative 1. Pick a couple of smaller numbers, a couple of bigger numbers. Okay, start with the smaller numbers first. Negative 1. Negative 1 squared is 1. Negative 2 times negative 1 is 2. So 1 plus 2 is 3. If I put 0 in, x squared is 0. Minus 2 times 0 is 0. 0 minus 0 is 0. And since it's quadratic, you could just copy these two numbers over here because they're going to be symmetrical. Okay? Since that's the case, we're going to plot these points. 0, 0, negative 1, 3. 2, 0, 3, 3, and so forth, and we graph it using a smooth curved line. Okay, and we got a graph of a quadratic function. So that's not the goal of this. This is part of it. So a quadratic function looks like a U, opens up or down. Okay, next thing is we're going to figure out our domain. I've taught you domain before. Domain is how far left and right does it go. So when does it start on the left? Well, this really goes up forever, and it keeps going to the left forever. So the word for forever in math is infinity, so it starts at negative infinity. Doesn't really touch it, so we use this sign. It never gets to truly to infinity because it just goes on forever. So we use this sign that says it doesn't, we don't know when it ends, but it's going to be there. It doesn't touch it, comma, and it keeps going on to positive infinity, right? It keeps going up, 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 and to the left, or right, I'm sorry. So we put positive infinity. It gets there, but it doesn't touch it. The range, we ask ourselves, how low is it? Well, it starts really here. This is how low it gets at negative 1. And the graph is touching at negative 1, so we're going to include it. So this is going to be a bracket, comma. And then it goes up to positive infinity. So it doesn't ever touch positive infinity, so it's going to be a parenthesis there. And then I'm going to do the vertical line test. This is the last step. Vertical line test. So I'm using a vertical line on here, and I'm asking myself, does this vertical line, how many times does this graph touch the vertical line? Well, it always touches once. If it touched twice, let's say it looked like a circle, then it wouldn't be a function. But this, what we're checking right now, we're asking ourselves, is this a function? And this is important because when you go to Algebra 2, you're looking at graphing, you need to know what a function is or not. So this is a function. It only touches once. Okay? That's it for number 1. So what I'd like you to do is talk to your neighbor about number 1 really quickly, and then I'm going to show you the shortcut that I taught you already on number 2. Does that go? Okay, on number 2, I'm not going to make a table, so I'm going to, you see this, sorry. You see this last step on the bottom left? We're not going to do that part, but we're going to do everything else, and I'll show you a shortcut to get through that more quickly. So, first thing, figure out your A, B, and C. Just like normal, you should just be able to automatically see what A, B, and C are. And then we're going to do negative B over 2A for our vertex, which is going to be, we're using this negative B over 2A, and you plug it in. So it's going to be negative 8 over 2 times A, which is negative 4.
Isn't it supposed to be negative 6?
Oh, thank you. Over here. Okay? Still doesn't affect where we were. So we're at 8 over negative 4. So we're at 8 over negative 4 is going to be really equal to 2. So our vertex is at 2 something. To get the other number, you plug it back in. 2 squared is 4 times negative 2 is negative 8. 8 times 2 is 16, so negative 8 plus 16 is positive 8. Minus 6 is positive 2. So our vertex is at 2, 2. So we go to 2, 2, and we plot the point, okay? Then we're going to do the left, right, 1 method, okay? Which means if I go left or right 1, I'm asking myself how far down will it go or how far up will it go. On this example, we're going to notice it's going to go down, and I'll explain why. So we go back to the first term, and since we're going to go left, right, 1, we're going to put 1 only into the first term. 1 squared is 1 times negative 2 is negative 2. So if I go left 1, I'm going to go down 2. And if I go right 1, I'm going to go down 2. So we should have a point here and here. Those are 2 points that should be on this graph. Next thing I'm going to do is go back to the vertex and ask myself, if I go left or right 2, how far down will I go? So I put 2 back into the first term. 2 squared is 4 times negative 2 is negative 8. So I'm going to want to go down negative 8 on each of these, which is going to be right there. So we're going to have a point here and a point here. So this is what our graph will look like. If you understand the shortcut, this helps you save a little bit of time. It is a lot easier, but if you don't get it, then just stick to example 1. It's fine. Again, we're going back to, now we're doing what we did first in the first problem domain. When does the problem, or where does this graph start on the left? Well, it keeps going on down toward the left forever, so our domain is going to be negative infinity, and it doesn't ever touch infinity, so we use that parenthesis, comma, and it keeps going to positive infinity. And then our range is going to be, it starts, when does it start at the bottom? It starts at negative infinity. And it goes up to positive 2. And it touches positive 2, right? So we're going to use a bracket for that. And parenthesis there. Now we're doing a vertical line test. And you're going to notice with all your quadratics that they pass the vertical line test always because they only touch once. Okay, so we would say this is a function. And that's it. Okay? So now 2's, remind the 1's about number 2, how we did that shortcut. Ready, set, go. Number 3. Okay? So working with your neighbor on number 3. Working with your neighbor on number 3. Working with your neighbor on number 3. You don't have a, I'm sorry? Oh. Okay, so figuring out the vertex, you're going to figure out only the vertex. I don't want you to write down the graph yet. I want you to just tell me the vertex first. Work with your neighbor. So we want to figure out what's negative. Our vertex is going to be negative b over 2a. Okay? Negative b over 2a. And we're asking ourselves, what is that vertex? Once you get this number, plug that back into the equation to get the second number. Go. If you're not getting it here, we got negative 12 over 2 times a, 2 times 2. So this is like saying 12 over 2 times 2, which is 4, which is just really 3. So our vertex is at 3 something, right? And then we plug 3 back in. So instead of x, we're putting 3 in. So 3 squared is 9. 9 times 2 is 18. Negative 12 times 3 is negative 36. So what's 18 minus 36 plus 16? Go. I just want to see your vertex point first. Again, your vertex is 3, negative 2, so you plot 3, negative 2. Oh, by the way, do you know if this opens up or down? Okay, you know it opens up or down by looking at A. What's A equal to? 2. 2. Is it positive or negative 2? Positive. If A is positive, it opens up, okay? So this opens up. You guys want to do the XY method, the chart, or the shortcut? Shortcut. Okay, shortcut. So if I go left 1 space, how many spaces will I go up? Someone? 2? Good. That's right. If you go 1 squared is 1 times 2 is 2. So you're going to go up 2. So we should have points here and here. Okay? If I go left or right 2, how far up will I go? 8, right? 2 squared is 4 times 2 again is 8. So you're going to go left 2 and up 8. Right? So I should have a symmetrical graph now. So I'd like you to finish this off. I want you to draw the graph and then tell me the domain, the range, and tell me is this a function or not. Ready, set, go. By yourselves. Finish graphing it for me on yours. I want to see your graph like mine. And tell me what the domain, the range, and finish graphing it. Go. Example, the domain starts from negative infinity, and it's got a little parenthesis, and it goes up to positive infinity. The range is going to be from, what's the lowest point? Negative 2. And it goes up to positive infinity on the range which is the up and down. Next thing we ask, is this a function? Does it pass the vertical line test? Yes, so this is a function. Okay? Because it's infinity is like a concept, and there's no point that's called infinity. It's not like, oh, there's infinity. You see where my pencil is? That's where it is. Infinity goes on forever. So you can never really grab it, because if you ever got to infinity, you could always go to infinity again. So this line it never touches infinity in one direction. But over here, does it touch negative 2? Yeah. It touches it, right? There's a point, it goes to negative 2 and then comes back. So since it's touching it, that means it's like exact. Yeah, exactly. It includes it. Okay. Good question, okay? All right, let's go to number 6. I want to show you something on number 6. Now, number 6, I got a question for you. What kind of graph is this? Is this a quadratic, linear, cubic? Which one is it? Turn to your neighbor, tell him which one it is.
It's linear.
Okay, it's linear, right? How do we know it's linear? What's the exponent above x? 1, right? So this is x to the first power. So we know it's linear. Now let's graph this and tell me, is this a function or not? Go. So in this example, it's a vertical line, right? Yours should look like this, right? If I did the vertical line test on this vertical line, how many times does it touch this graph when I cross it? How many times does it touch it? Infinite, right? It touches here, 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 here. It touches at every point. So since it touches at every point, it's not a function, okay? Yes. No. Okay? So this is not a function. Not a function. Alright? And that's it. That concludes the lesson for today. So please